Thank you, all of you, for being there. I'm going to try to explain from Red Hat point of view what we are seeing in this telco transformation and how this navigation, as you can see in the picture, well, it's taking some time. Yeah, I'm gonna talk a little bit based on what we just discussed, a little bit about what are the three main forces that are paving the way when it comes to telcos. Of course, we are talking about the 5G. 5G is nothing much. It's about the evolution. It's already in place. That's why we can consider in green. AI and machine learning has been used by telcos for a while, but now it's about how they can get the most thanks to these new capabilities and how they have to leverage it. As I said, they need to fix issues. They need to find the goals and maybe how they're gonna use AI to fix it. And cloud native. And cloud native, I'm putting it in red as I explained right now because there are certain issues to be fixed when it comes to telco. This is a survey coming from the TM Forum, July 2024. And the good news is 92% of the service providers, they are fully committed to the cloud native approach, but they acknowledge that when we talk about network functions, there are some hiccups that they need to address. And this is true. If you check what is the evolution, this is a tracker, again, this is from Analysis Mason. This is a tracker about the 5G network cloud deployment. The first one, the vertical integrated, as you can see, is slightly going down. This is the solution coming from the telco NEPs when everything they provide everything, the CNFs, the platform, everything is coming from them. The telco private stack is where telcos of the world service providers are using third-party technologies like Red Hat technology to onboard 5G. And as you can see, it's getting up as very, very timid. And the last one is the hyperscaler stack that is still flat in around 8% there. Why the vertical integrated is going down? It makes sense because after the first phase, which was 5G core, now service providers are onboarding new network functions. We have seen a few of them onboarding RAN, others onboarding other core networks, like core elements like voice or policy charging, etc. So when you want to have the same, let's say, data center, different network functions from different vendors, maybe the vertical integration doesn't work that much. And that's why the natural answer is, okay, I'm going to try to find a solution. The solution could be the telco telco private networks, the common platform that service providers are deploying. But at the same time, as you can see, it's not ramping up. And it's not ramping up because there's right now, there's a challenge when it comes to manage this lifecycle management and the operational model and the way to maintain CNFs on this platform. That's the reason. As I said, we are seeing that the gap is narrowing, but it's still not as we wanted. And also we have to bear in mind that this is, and always I use this sentence, the telco cloud is an evolution and it's never going to be a revolution. Talking about the telco cloud native platform, let me spend 2 minutes talking about that. The magic, let's say, of a telco cloud platform, it has to be that it's able to adapt and be deployed in as many different environments. Doesn't matter if it's public cloud, private cloud, data center coming from the CSPs, the edge data centers, or the far edge. And at the same time, they have to be able to support different type of network function or different type of workloads there. So that's let's say the final goal of having this common platform or single pane of glass when you need to deal with the different environments and the different application and workloads. If I have to define or find one word to define what is expecting from this telco cloud native platform, is consistency. It has to be consistency through a unified cloud native infrastructure that it has to enabling reuse components for seamless deployment, operations, monitoring, scaling, etc. So we want to have one operational model for onboarding CNFs, for upgrading CNFs, for scaling CNFs. So one single lifecycle management. We want to have one single security framework, etc., etc., etc. Okay, so now let's focus on the cloud native aspect of the applications, okay? There are many definitions about what is cloud native, but more than the definition, I want to be focused on the characteristics. And there are 4 characteristics that they define cloud native application. The first one is service-based microservices. We are seeing more and more. This is an evolution, and this is happening. The second is APIs. We talked about APIs in the previous panel, so I'm not going to spend much, but again, it's needed. Containers. This is not anymore about VMs. Now it's about containers. And again, we are seeing this an evolution when it comes to cloud native. And the final term maybe is a little bit less well known, which is platform engineering. And it's an evolution from our point of view of what before was called DevOps. Platform engineering brings 3 different components. It's about the pipelines, the CD, CT, CD pipelines, the GitOps approach that you need to have there, and observability. Putting these 3 components together, so you can create the essential infrastructure, you can make development processes efficient and secure. So fine, now that we have defined these 4 characteristics, let's have a look to what is the situation with the CNFs, with the containers network functions. In terms of service-based, fine. We can argue that maybe we need to have more microservices as part of one network function in order to simplify the upgrade process, in order to reduce dependencies between different components, also to make sure that the in-service upgrades can be done more often, et cetera, et cetera, et cetera, but it's happening. APIs, again, it's happening, it's well established, no problem here. When it comes to containers, the main problem that we are seeing is that not every single telco NEP has defined what is going to be transition from virtual machines to containers. And if you are not able to have this transition program or journey already in place, it's going to be difficult for the service providers to grade their own journey about how they're going to start leaving the world of VMs and start thinking more about containers. And the final one, the platform engineering, definitely there are room for improvement here. There are room for improvement here because these new operating models has to use and rely on GitOps, and right now still not that established. It's very established maybe for IT application, etc., but not for network functions. These cloud native transformations should not be limited to the application and design and development. As I said, it has to be also part of this network operational aspect. And using this common Git repository for the application, also for the infrastructure, et cetera, can simplify this complexity and the dependencies between the infrastructure and the application. That's what something that we are seeing more and more in this area. So let me now explain how this platform engineering can match and can be part of this lifecycle management, or how we are going to manage the telco cloud network and all the different applications here. And let me share with you, this is an overview coming from Analysis Mason 2, is vendor agnostic, that's what I use it, about the cloud native automation framework, or a service management orchestration, whatever you want to call it. And if you want to identify the platform engineering, it's there. So it's a little bit of GitOps and the inventory in this part. We have then the different domains, the network functions domain, the CAS layer domain, and the infrastructure domain. We have the observability at the right. And also we have these components of the declarative model when we talk about a small automation for each domain, for the network, for the CAS layer, and for the infrastructure is something that we're going to have also there, plus all of the control loops or the GitOps controllers that you need to have there. Again, this is if you have to identify in this high-level view of an SMO where we can identify platform engineering. All these components of platform engineering, the good things are based on open source projects or upstream based. So that's very good to implement it as a single component. The second layer that we have is the generative layer as part of this orchestrator, this SMO, and it's more about the how to say that. It's about the telecom network domains, a specific layer. It's about when you can, it's a layer that they can completely understand the network components, the topology, and kind of serves and enhance the operations, right? In a nutshell, is kind of the brain of the overall solution. And here is when we are seeing more and more intelligence needed. And when we talk about intelligence, we're going to go back to machine learning and artificial intelligence. Here is when the vendors who are designing this SMO is when they put in the biggest effort, because this is when they're going to have the differentiation compared with other solutions. So let me now very quick navigate on the automation journey. I'm going to leave behind everything related to the use cases assistant human decision, and I'm going to be focused more on the holistic automation. In the holistic automation, telcos right now are in this journey. I guess the first step is the collaborative automation, and it's already in place. We are talking about here multi-vendor open loop automation in order to assure consistency end to end. The second milestone step is automation at a scale. We just mentioned when we talk about platform engineering, it's about the declarative model, it's about the domain automation, and it's about being able to managing and provisioning through code. And this is in the state that telcos are working right now. And the final one is this automating the whole business, which is about actionable intelligence. It's about the natural language processing for network operations, AI, machine learning, being able to predict in real time and take actions in real time. In a nutshell, is what we call autonomous network. And here is the thing, when we want to have this proper lifecycle management of this telco cloud platform to manage the network functions, where the investment and the focus has to be put on. Again, what we try to achieve here is this automation assisted by artificial intelligence. So in a nutshell, I'm trying to summarize what I explained until now. We have the cloud native concept that we know that is going to be needed to deploy 5G networks today, probably 6G in the future. Also, we have to see how we can place artificial intelligence and machine learning as part of this feature in order to improve, if we talk about NSMO, the overall performance and the operational framework. So I'm going to try to, now that we have all of these pieces together, I'm going to try to give you a couple of examples about how, when you put all these together, we can see the reason and the benefits behind that. I'm going to start with something very simple. It's a mobile network. We have the RAN deployed in the far edge, everything distributed there, and the 5G core deployed on an original site, so fully centralized. This is very easy. We are using also the Telco Cloud Native platform in order to manage here and there. And again, very simple example. The next step is how the network can be able to adapt to different needs. Could be the next need is, okay, we can, if we think about private networks, for instance, we maybe need to have the UPF, certain core functions closer to the customer. And also at the same time, we can centralize part of the RAN, like the CU, in order to be more efficient, just for the sake of clarity here. And again, if talking about network slicing, as you were talking before, network slicing also can be implemented here. But this is just about connectivity. So far, we have done nothing more than being able to work with the SMO capabilities to adapt our network based on network functions to be more to cope with demand coming from a customer or from the network itself. Fine. The good news here is this can be done fully automatic. That's what we need to achieve. This is the final goal when it comes to think about cloud native platforms, right? The next step could be, all right, this is only connectivity. What about services? If I have to provide a final service to the customer, what else I have to do? And what you have to do is add in these applications. In this case, I'm talking about AI applications because this is the example that we have been doing lately with SoftBank, and I will explain what is the point. Right now, let's see what is the final outcome after this DeepSeek approach, but we're going to need GPUs, fine. We're going to need to change our hardware, and this hardware, we know that GPUs are super powerful. So we have to get the most of them in order to justify this investment. How we can justify this investment in a, let's say, or service provider can justify this investment if this technology or this platform can be used not only for AI applications, but also for the RAN, in this case, or for the 5G core in the future, okay? So this is what we call this multi-tenancy approach. And this is a big differentiator because as of today, if you talk with service providers, the majority of them, they spend a huge amount of money in the deploying RAN, and it's just for the RAN, just for providing connectivity. Here we are talking about embedding not just only the keeping the lights on as connectivity, but also being able to leverage this platform for final applications. Okay, let's go one step further. Let's forget about private networks and let's be focused on public networks. This could be, and this is very similar to what we did in Japan with SoftBank. If we remove the UPF, is let's think about in an urban scenario where we can have fiber nearly everywhere. How can we get the most of these features? So we can centralize the DU. We can send all of the RAN capabilities to the edge data center. Hence, we don't need to have computing capacity in the RAN site. Hence, we are going to save some money there because RAN sites are not always 100% utilized. In the other way around, usually is only a couple of hours where they can reach certain level of high utilization. The rest of the time, they are underused. So we can try to leverage these, saving money there, centralizing part of the function. And at the same time here, what we're trying to do is, as I said, reuse this capacity, RAN capacity, and AI application capacity dynamically based on the needs that we have. For instance, if it's peak time and we need to allocate more capacity to the RAN, there you go. You will have more capacity allocated for the RAN dynamically. If it's not the case and you want to, let's say, leverage this extra capacity for AI application, is something that you can do. In Japan, what we did with SoftBank, they deploy 3 different AI applications that are very common. So the first one is autonomous vehicles for over 5G in one specific area. Another was in a factory for the multimodal AI applications, and also robotic applications. So in a nutshell, this is the first breakthrough about what we are going next, which I'm going to try to explain in the next slide. I tried to avoid bullet points slides, but in this case, I tried to summarize what I have been presenting here. As I said, this telco cloud platform at the end, what we're trying to achieve is harnessing the full power and the full potential coming from 5G together with AI. And for that, and this is something that we have seen, is first, it will facilitate new use cases and synergies between CNFs, AI, artificial intelligence and machine learning applications, and also B2B and B2C services. It will also optimize performance, efficiency, and scalability for 5G services. As we see, you have the SMO implemented there, and you have also these capabilities deployed here and there. You will achieve that. Also, this telco cloud platform, it has to be evolved to be also an AI platform, what we call the telco AI machine learning cloud native platform, able to model or to host also the foundational models, all the data, etc., etc. It's going to be also needed. Also, will strengthen the AI and network synergies. Right now, we have three working groups about AI and networks. The first one is AI in networks. The second is AI with networks and networks for AI. It will also establish a fundamental model for the evolution of 5G and towards 6G, focusing on converged RAN and core network function that we are going to see when we talk about the next evolution of mobile networks. It will define the next generation of mobile networks that they have to be fully end-to-end network as a service. It has to be also service-based and an AI-driven architecture leveraging these neural networks that are coming. We have seen this, and we have proved that, as I said, in Japan in 2024, in order to achieve this multi-tenancy capacity, that it will help service providers to invest in a much efficient way. And then finally, the next focus area, it will be the IP transfer. We believe that there will be fantastic changes and very challenging changes coming in the next years in terms of developing this software-driven IP transport that has to be also A-powered and also cloud-based. Let's see how it's going to arrive there. But something that we are seeing as of today is that more and more this telco cloud platform is the fantastic tool that is needed to put together the technology coming from the connectivity, but also the applications needed for their services. And that's all from my side. I usually try to close all of the session with this sentence: is that you have to define your telco cloud strategy and don't let the cloud define yourself. So, Annie, this is all from my side. Thank you so much. I'm happy to take any question, if any.
Thank you very much. That was really interesting, actually. We have a question from the audience, from Alexandra, and she says, regarding autonomous network, what is the risk and how much human oversight is involved or needed to intervene when there's an issue? Well, I guess there's always the off switch, but...
Yes, and well, that's something that, of course, it's not that you are gonna let networks to do everything by themselves since day one. So it's gonna be like tutoring, and you have to see what is the outcome. And when you feel comfortable with this outcome, is when you're gonna fully rely on this, right? I do believe that telco networks and the whole architecture is getting more and more complex. So unfortunately or fortunately, we are going to reach certain level where we are not going to be able to understand everything that is happening. And in some cases, maybe these autonomous networks, they're going to take certain decisions that maybe they are not very, let's say, logical for us. But from their point of view, they're going to be able to be there. So I think before going into blindfolding, let the network to be operated as they want, we have to check what is the final outcome. We have to see if this outcome makes sense. And after that, let's see what else they can be done.
Okay. I have a question for you too, although we're very nearly out of time. What are the key concerns and challenges that Red Hat is helping telcos overcome with a move to cloud native platforms? Because I do think, and we're going to have a session on this shortly, I think one of the issues about the migration to 5GSA is something of a fear of the cloud native environment.
Exactly. So
that's new, isn't it? I mean,
yeah, but at the same time, as I said, I think what we're trying to do here is we are working very hard with the telco NEPs to understand how they are designing and defining their network functions in order to see what is the best approach when we want to onboard these CNFs as part of our platform. And from the other side, we are also talking with many service providers to understand, okay, what else do you need? And as I said, the final goal that we have right now is we need to improve the lifecycle management and the operational model of the CNFs in a telco cloud if we really want to achieve what we want, which is something more, let's say, less painful, more dynamic.
Okay, so that's quite a pragmatic step.
Yeah, exactly.
It's not something really blue sky.
Yeah, exactly. We have to steer the wheel right now, step by step. We have advanced a lot compared with we were maybe 4 or 5 years ago, when even people, they were not super sure that if a Kubernetes platform is going to be the right one to support network function. I think we passed that stage already, and now we are saying, okay, now we know that it works. How we can make it works, let's say, smoother and more dynamically to achieve this autonomous network as the final goal. That's for me what I'm seeing.
Also, it's translating from, okay, I understand it works. How do I make it work really, really well for me?
Exactly. Yeah.
Okay. Ignacio, thank you very much indeed. Much appreciated.